How's it going? This is Mr. Murray coming to you with a quick video breakdown on the lesson performance task that I did on 317. And this was related to, if I can get this up, this was specifically found in the section on Law of Cosines. This was a Law of Cosines performance task. And also, I believe in the sheet I hinted at, you do also need to know the area formula that we talked about. So the Law of Cosines was discussed in 3 dash, I believe it was 12. And then in 3 dash, I want to say 11b, we talked about the area formula, which is 1/2 AB sine C. In other words, the two sides and the angle and the other angle, right? So if I knew, I take the two sides and the angle essentially in between them, and that will give me the area. Okay, so what I have here is in the middle of a town, State and Elm Streets meet at an angle of 40 degrees. A triangular pocket park between the streets stretches 100 yards along State Street and 53.2 yards along Elm Street. Okay, so the first thing we need to do is find the area of the pocket park using the given dimensions. What we know is that we know the area is equal to 1/2, all right, 53.2 times 100 times the sine of 40 degrees, and that's what we would plug in. 1/2 53.2 100 sine 40. Okay, and it doesn't matter what you set your A and your B to, because you're going to multiply them by each other either way. Let me just do a double checker there. So the area, wow, that's actually a really big area. But actually, if you multiplied 100, it's not actually that unreasonable, given the fact that one of them is 100 and one of them is 53.2. So the area of the park, let's say, we're not told how to round, so it's rounded 2 decimal places. If you didn't, I didn't make it clear, so that's okay. Or maybe I did in the Google Sheet. You'll have to check. So 1,709 point, how do we go, 82 yards squared, or square yards. Please make square yards. It's yards because we're given yards. It's square yards because you're doing area. And actually, when you did 53.2 and 100, that was, you also did the yards times yards, and that's where the yards squared came from. All right. Question B, if the total distance around the pocket park is and I'll move this, it said 221.6 yards. Find the angle S, which is the angle that West Avenue makes with State Street, to the nearest whole degree. So here we're actually being given a little bit more guidance with regard to our units. We're told that it has to actually be to the nearest whole degree. So that's going to be important. Okay. So I'm going to mark this off. And what I know is that this is my angle S. And here, this is kind of a bad drawing. This is supposed to be up here. It's supposed to be as little s. So what I know is that the sine of big S over 40 is equal, I don't know where I got 40 from. The sine of big S over 53.2. Set up our sines. I don't know why. Giving me a hard time right now. So the sine of S over the angle, over the side that's across from it, is equal to the sine of, now what angle is across from 40? Well, we can actually figure that out because we know, first of all, let me set up 40. We're told that the pocket park is 226 around. In other words, this 53.2 plus the 100 plus whatever this is equal to 221.6. So I'm going to take my 221.6. I'm going to subtract out State Street's length. I'm going to subtract out Elm Street's length. Not bad. And I get West Avenue is 68.4 yards. Okay, so that they all add up to the to what we were told. If I did not give you 221.6, this problem would have become a lot harder to do. And in fact, you may not be able to use the law of sines to even do it. Okay, and so remember, this is actually done before you're supposed to do the law of cosines. And so ordinarily, you would need the law of cosines if you did not have this information to figure out that this was 68.4. Okay, so that's why they gave you that, because you only with the law of cosines would you otherwise be able to solve it. So here's my setup. And so what I know is that the sine of s, if I just simplify, not the sine of 8, the sine of s. Get my eraser back. So the sine of, I'm struggling to explain why my smart notebook is giving me a hard time today. 53.2 times the sine of 40 over 68.4, which means that s is equal to the sine inverse of 53.2 sine of 40 over 68.4. And let's figure out what this is. So second sine, to pull sine inverse, 53.2 times the sine of 40 divided by 68.4. Okay, I get 29.99. So that means the nearest degree. So we know s is approximately 29.99. So we're going to round, and that's degrees. So we're going to round that to 30 degrees. And to confirm its degrees, I'll again do second mode. And my calc's giving me a hard time. What fun. Well, ordinarily what you should be able to do is if you do second mode, let's try one more time. Nope, it's not going to do it for me. So ordinarily when you do second mode, you should be able to see that you are in degree mode. To confirm I'm in degree mode, let's do sine of 30. And I get 0.5. And I do know that sine of 30 degrees is a half. Okay, so great. Here we go. We have 30 degrees to the nearest degree is the measurement of that angle. Finally, suppose West Avenue makes a 55-degree angle with State Street. Okay, so we need to rethink this. So let's wind it back, because we're in a different kind of supposition. We're in a different scenario. So suppose West Ave makes a 55-degree angle with State Street and an 80-degree angle with Elm Street. This is an interesting situation because how does this work? You got to ask yourself, how do you get this to add up to 180 degrees? All right. So suppose West Avenue makes angles of 55 degrees with State and 80 degrees with Elm. I don't know why they're having us do it this way. Again, what I'm getting at is you can see this is a little bit nonsensical. Because these should add up to 180, but for whatever reason they don't. Whatever. The distance from State to Elm along West Ave. So the distance from State to Elm along West Avenue is 40 yards. Find the distance from West Avenue to Elm along State, which means what I want to know is distance from West Avenue to Elm by going across State Street. Okay? So in other words, what's this? And what I notice here is that, again, this, whatever it is across from this angle. And this, whatever it is across from this angle. Now, here's the thing. I think we're supposed to look at this a little bit differently, because it doesn't make sense to me that this would work out that way. So I think what they want me to do is I believe they want me to set up a new triangle, because let's take a look at what this is. This is State, and we don't know the length of this. This is West, and this is Elm. So let's start with a blank slate and put in what we know. So what we know is that west makes a 55-degree angle with state. So this would be 55. And it makes an 80-degree angle with elm. And we know the distance from state to elm. So in other words, to get from here to here along West Street is 40 yards. I need to find this distance right here. Now, here's why I'm thinking that we need to know this. Because again, look at what we're given. I'm given angle, angle, side, okay? If I want to know what's going on with this side right here, I'm in a little bit of a bind because actually what I really have is my known is angle, side, angle. And I need to find this side right here. So if I don't know this angle, the law of cosines is not going to work because I'm going to have an unknown here, right? So let's say I call this A, I call this B, and I call this C. In other words, what I'd have is I'd have sine A over 40 equals sine of 80 over the distance. And notice that we don't know A. I don't feel right calling it 40 because if you call it 40, these don't add up to 180. So I think with the given information that this is actually 45 degrees. So now I get 45, 50, 80. Okay. And now I'm going to plug in. So I know that sine A, so I've got sine of 45 over 40, and 45 happens to be a special sine value, equals sine 80 over that distance. And now see, there's only one piece of unknown information. So what I have is that the distance times the sine of 45 equals 40 times the sine of 80. And so the distance is equal to 40 times sine of 80 over 45. Now, some people might say, but Mr. Murray, like I really honestly believe that what I'm supposed to be doing here, sorry, this should be sine of 45. What I'm supposed to be doing here is use 40 because isn't that what was in the diagram above? But here's the thing. Again, if you make it 40, then the three angles will not add up to 180. And so if this is going to be a triangular, that just doesn't jive with me. That's not going to work. So let's figure out what the distance is. So I've got, and does it give me, it doesn't tell me what to round to. So let's start with this. 40 times the sine of 80 over the sine of 45. And I get 55.7. How about we call it, let's do two places. 55.71 yards. And this kind of makes sense if you think about it again, because 80 is more than 45. And so we'd expect the side length across from 80 to be longer than the side length across from 45. Okay, so hopefully you found this breakdown informational. This was just meant to be an application question to see whether you could suss out how to use the law of sines and given information to solve for certain unknown variables. I probably will not do this with law of cosines because there's a little bit more context already in that packet, but please make sure you understand these kinds of problems because this is the kind of problems you'll most likely be faced with in the longer term. All right, so keep the questions coming. Remember, we do have a hangout hopefully coming up soon where you might want to write down questions to ask for that, but keep it coming, keep the positivity flowing, and remember, you can do it. All right, thanks so much for watching. Have a wonderful day, and don't forget to love math.